All right, let's dive right in. Today, we're going to unpack the incredible story behind one of the most famous charts in all of science, the periodic table. You've definitely seen it hanging on a classroom wall, but trust me, it's so much more than a poster. It's the final chapter of a centuries-long detective story full of curiosity, dead ends, and a few moments of pure genius.
So picture this. You're a scientist, and you've got this ever-growing list of stuff. Some are shiny metals, some are weird invisible gases, others are just powders. And they all act in totally different ways. The huge question that had everyone stumped for centuries was, how do you make sense of it all? Is there some hidden pattern to all this elemental chaos?
For most of human history, elements were just things, useful materials. Gold, silver, iron. People knew them, people used them, but they were all just individual items on a shopping list. There was no connection between them, no underlying rulebook for how matter was put together. So, how did we get from that total jumble to the elegant grid we all recognize today? Well, the journey started with the very first attempts to find a pattern, to find the first few clues in this massive elemental puzzle.
The first really important step came from Antoine Lavoisier back in the 18th century. He made the first real scientific attempt to organize everything, and it was pretty simple. He just split them into two big groups. You had your metals, and you had your nonmetals. Hey, it was a start. Then in 1829, a chemist named Johann Dobereiner noticed something much more specific. He found that some elements fit perfectly into little groups of three, which he called triads.
So, for example, take lithium, sodium, and potassium. They're all soft, super reactive metals. They're like cousins. But here's the really cool part. Look at their atomic weights. The weight of the middle one, sodium, is almost the exact average of the other two. It was this amazing hint that there was some kind of mathematical logic hiding right under their noses.
Okay, so these triads were really interesting, but they were just small, isolated groups. The next huge leap forward came from a scientist who didn't just see little groups, but saw a repeating rhythm, a beat, that ran through the whole list of elements.
So in 1864, an English chemist, John Newlands, lined up the elements by their atomic mass, and he noticed something totally wild. He called it the law of octaves. Why? Because just like a musical scale, the properties of the elements seemed to repeat every eighth element. It was the very first whisper of what we now call periodicity.
Check this out. If you start with lithium, right, and you count 7 elements down the line, you land on sodium. And guess what? Sodium acts a lot like lithium. This was the first time anyone had seen this kind of predictable, repeating pattern across a long string of elements. The puzzle pieces were really starting to click together.
So you have all these clues piling up, the triads, the octaves, these little hints of a pattern. This is where the master detective of our story comes in. A guy named Dmitri Mendeleev enters the scene, and he's the one who finally cracks the code. In 1869, this was the magic number, 63. That's how many elements were known at the time, and Mendeleev, a Russian chemist, decided he was going to organize all 63 of them into one single beautiful system.
So Mendeleev also arranged the elements by atomic mass, but he did something that was totally radical for the time. When the next heaviest element didn't fit the properties of the column it was supposed to go in, he didn't just shrug and stick it there. No, he bravely left a gap. He trusted the pattern more than he trusted having a complete list. And this is what made him a legend. He didn't just leave blank spaces. He made actual testable predictions. He basically said, hey, there's an element we haven't found yet that goes right here. And let me tell you what it'll be like. Its mass, its density, probably even its color. I mean, the nerve. And then years later, when scientists discovered elements like gallium, they were a near-perfect match. It was incredible. And that's exactly why we call him the father of the periodic table.
Mendeleev's table was an absolute triumph. But there were still a couple of little quirks, a few elements that just seemed a tiny bit out of place. The story wasn't quite done. There was one final key needed to unlock the true secret of the table.
So almost 50 years pass after Mendeleev's big breakthrough. Then, in 1913, this young physicist named Henry Moseley, using some brand new X-ray tech, figured out what was really organizing the elements all along.
So here's the tiny but incredibly important difference. Mendeleev had used atomic mass, which is basically how heavy an atom is. Moseley discovered the real organizing principle was the atomic number, which is just the number of protons in an atom's core. When he reordered the table by atomic number, all those little inconsistencies that had bothered Mendeleev, they just vanished.
Poof, it was perfect. And that gives us this beautiful, simple statement. This is the modern periodic law. It's the definitive rule that governs the table we use today, and it reveals the hidden order of everything in the universe. Pretty cool, huh?
So let's just take a step back and appreciate this whole journey. What started out as a totally chaotic puzzle over a couple hundred years became one of the most powerful and essential tools in all of science.
You can really see this straight line of discovery, right? Each scientist stood on the shoulders of the one before them. Lavoisier started with a simple sorting. Dobereiner found those little family groups. Newlands heard the repeating rhythm. Mendeleev put the whole puzzle together and even predicted the missing pieces. And finally, Moseley came along and gave us the ultimate cheat code.
And why does any of this history matter? Because today, the periodic table is absolutely vital. It's the roadmap for all of chemistry. It helps us understand why things are the way they are, predict how chemicals will react, and even guides us as we search for brand new materials. It's literally a map to the matter that makes up our world.
Which leaves us with a really fascinating thought to end on. The table isn't done. Scientists in labs right now are smashing atoms together to create new, super heavy elements, pushing the boundaries of this chart even further. It just makes you wonder, what new patterns are we going to find? And what's this iconic table going to look like in another 150 years? The puzzle, it seems, is still being solved.